Hello, folks. Today I wanted to talk to you about some modern theories of consciousness. Specifically, I'll be talking about the role of qualia and quantum mechanics in these theories. At first glance, some of you may look at that title and get two big question marks above your heads. I will do my best in this presentation to provide a brief and hopefully digestible explanation of what those terms mean. I'll then describe two unsolved problems related to those terms, and finally, I'll discuss modern research findings related to this field of study. To describe qualia, I like to imagine stopping to smell the roses. As you stop to smell the roses, you're having many experiences of those roses that you may have trouble relating to another person in their full sense. Their color, their smell, or even something more abstract like the feeling that a rose brings up to you. These are all examples of qualia, a term that describes our subjective conscious experiences. Qualia are what build up our sense of a conscious self. To put it more simply, to be conscious is to experience qualia. To be unconscious is to not experience qualia. A nice description of qualia from Phantoms in the Brain is the following. To provide stability for you as an organism surrounded by a bunch of stimuli, at some point you need to say, this is it, and plant a flag on it, and it's the planting of the flag that we call qualia. And now I want to move on to quantum mechanics. This slide is a very surface level overview of what quantum mechanics is. However, this gives a surface level idea that will be just enough for what I want to talk about. Imagine you were able to zoom in continually on a person's arm until you couldn't zoom in anymore. What would be at the finest level of detail? At the quantum scale, particles like quarks, photons, and gluons, among others, are constantly in motion and flux. Things at this scale are a lot less definite than at the scale of the person's arm. To give you an example of what I even mean by that, imagine this thought experiment first created by Erwin Schrödinger. You take these materials, you put them in a box together, and you leave the room. Because the isotope is subject to the probabilistic nature of quantum particles, meaning that there's a 50% chance that it will have decayed after 30 minutes, thus dispensing poison and killing the cat. When you come in to check on the cat after 30 minutes, before you open the box, you have no idea whether the isotope has decayed enough to trigger the poison and kill the cat. Therefore, before opening the box and gathering more information, Schrödinger suggests that the whole universe exists in two possible states. One where the isotope decayed, the poison was emitted, and the cat is dead, and another where nothing has decayed and the cat is still alive. Schrödinger argued that when you check the box, you gain enough information about the system to cause the uncertainty to collapse into one of the two states. What this also seems to suggest is that the uncertainty of quantum particles can become entangled with a large creature like a cat. Now I'd like to talk about two major unresolved problems in the fields of psychology and quantum mechanics. The hard problem of consciousness has to do with how we seem to be unable to really nail down an answer to the question, why is a physical system, like a human, conscious? Furthermore, why are our conscious experiences so subjective and resistant to explanation to other conscious beings? To some, it seems that even if we were to explain all the scientific aspects of how a conscious mind works, these why questions would still remain. The measurement problem in quantum mechanics describes how the way a physical system, like Schrödinger's cat, evolves over time, seems to be governed by the exchange of information that an observer has with the system going from many possible states to one definite state upon observation. These two unresolved problems are being researched in a variety of articles, and while there are many different ideas, I found some articles that seem to have a consensus opinion around how these problems relate to consciousness. In this article by Kaufman and Rowley, they argue that our brain relies partly on quantum computation to help us process sensory information and form our own continuous, subjective conscious state of existence. In Beshkar's article describing their qubit theory of consciousness, they urge us to consider these problems from an interdisciplinary perspective. Beshkar proposes that we store uncertain, probabilistic internal models of qualia that collapse into one as our brains perceive and integrate sensory information. This collapse into certainty is what forms our conscious experience, according to Beshkar. Svetlichny, an emeritus professor of physics in Brazil, provided an interesting point of reference for this project. as his article was purely his professional opinion with no references. That being said, I think his points lined up well with what was presented in the other articles I had read, which were more modern. He also suggests that having unique conscious experiences is evolutionarily advantageous simply because it allows us to actively function in a universe that contains an overwhelming amount of information. If we're able to reduce many possible interpretations of a given set of stimuli into one subjective state of reality, we're able to go forward with more certainty and evolutionary fitness. That's all I have for my presentation, and I thank you for listening to me speak about this topic. I wanted to share a picture of me that kind of represents what I thought my partner might have thought I was looking like when I described what I was researching, which is this, because this is all very speculative, but it's just an interesting topic, so I appreciate you listening. Thank you. These are my references.